Okay, so today we're looking at finding the curvature. So, looking at this first problem, I wrote the formula, which we already have in our notes, and we want to find the magnitude of the cross product of the first derivative and the second derivative, and divide that by the magnitude of the first derivative cubed. Okay, so it says, we'll start here. Given the space curve r of t equals 4 cosine t plus 4 sine t plus 3t, and then it says for when t equals 4 pi over 3. So if, you may not remember, but if you do, the formula given to us is the formula for a helix, and the curvature is going to be constant. So we actually are not going to even need the 4 pi over 3 because the curvature will be the same at any point on the helix. Okay, so getting started, we want to find each of these pieces. So I like to rewrite r of t as 4 cosine t, 4 sine t, 3t. So it's just using your equation here and rewriting it. And then find the derivative. So the derivative of cosine is negative sine. The derivative of sine is cosine. The derivative of 3t is 3. And then we want to find the second derivative. So the second derivative is negative 4 cosine t, negative 4 sine t, and the derivative of 3 is 0. So then we found the first derivative, the second derivative, and now we want to find the cross product. So if you remember the cross product, we're looking at just these two here. So when you're looking for the first component, we're going to do 4 cosine t times 0, so 0 minus, and then multiply here, so that would be negative 12 sine t, and so 0 minus negative gives us that positive 12 sine t. Okay, so now looking at, to get your middle term, we look at negative 4 cosine t times 3, which is negative 12 cosine t minus 0. So there we go. Then for the last, our third component, we're going to look at negative 4 sine t times negative 4 sine t, which gives us the 16 sine squared t minus negative 4 times positive 4. So negative 16 cosine squared t, and since it was minus a negative, we rewrite that as a plus. We know that sine squared plus cosine squared is 1, so that's really 16 times 1, which is 16. Okay, so now we have the first derivative, cross product, the second derivative. So now what we want to do, let me do this, is we want to find the magnitude to finish the numerator. We want to find the magnitude. So we would say k equals the square root of, so 12 sine t squared becomes 144 sine squared t plus the middle component, which would become 144 cosine squared t. And then lastly, 16 squared is 256. Okay, so the next piece is we could go ahead and write out the denominator, but what I did in class was finish working the numerator. So I know that this part here becomes 144 times 1, which is 144, plus 256. So 144 plus 256 is the square root of 400, which is 20. Okay, so we have finished working with the numerator. So now we want to work with the denominator. Okay, so looking here, we want to do the magnitude of the first derivative cubed. So magnitude of the first derivative cubed. So that tells us what we're going to do now is look at here, and we're going to square the first, so that becomes 16 sine squared t, 16 sine squared t, plus 16 cosine squared t, 16 cosine squared t, and then 3 squared is 9. Now something you want to make sure you don't forget, because I did, and I don't know if this is going to delete everything. Good. Okay, is we want to make sure we don't leave off the cubed, because that is part of the formula. Okay, so now looking here, we know sine squared t, cosine squared t is 1, so that's 16 times 1 plus 9, and all of that is cubed. And we know 16 plus 9 is 25. So then that becomes 5 cubed. So then we have 20 over 125. And now we simplify. So 20 over 125. You can divide a 5 out of both and get 4 over 25. So give you a minute to look at that, and then we're going to write the conclusion, because we do need to make sure we clearly are communicating. Okay, so for the conclusion, I'm going to say the curvature for r of t equals 4 cosine t plus 4 sine t plus 3t is 4 over 25 when t equals 4 pi over 3. Also, the curvature, now you could leave it right here. Curvature is 4 over 25 at every point, because this is a helix. So we could say the curvature is 4/25 at every point. Since the curve is changing direction at the same rate at every point. Since the curve is changing direction at the same rate at every point. And so I'm adding that in there just for clarification. All right, so that is